All right. Independent events are those events. First of all, you have to have more than one event. Okay. There has to be more than one event for an independent or dependent event to happen. Okay. An independent event is one that can occur, and it doesn't matter. For example, let's say you had a spinner with a bunch of colors on it, and you had a dice. Okay, and you roll the dice. You want to land on a 3. You want to spin the spinner and land on a blue. Those two things are independent of each other. Has no effect. Rolling the dice on one thing and spinning the spinner on another has no effect on each other. Okay, if I want to get a deck of cards and I want to pull out a king of spades and keep it out, and then I want to pull out a king of diamonds and keep it out. Okay, those are dependent events. Okay, because one will occur without the other one because I'm holding the card back after I've picked it. Okay, another one that's very simple to understand. When you're in the summer in Texas, it's either going to rain or it's going to not rain. Okay? Those are two events that are totally, they're going to happen. All right? We call those complementary events like we've already talked about. But what do we need for snow? Cold weather. Obviously, it's not going to snow in the summer. Okay? If it does, it would be a major miracle. Okay? Especially in Texas. Okay? So you need to have something to happen before it can snow. Okay? That would be dependent. It's dependent upon something else to happen. All right, now, as we look at example 1, okay, the question under example 1, it says a jar contains 5 red and 7 blue marbles. You randomly choose a marble, put it back, then randomly choose another marble. Are the events to choose a red marble first and to choose a blue marble second independent or dependent? What did you put? Independent. They're independent of each other. Okay? Because you're putting the marble back. If I was taking the marble out and keeping it and then picking another one, then they're dependent upon each other. The reason they would be dependent is because you could fill out whatever it was they wanted red first. You could pull out blue marble second. So you could pull out a blue one first. And if you keep it, well, you've just changed your odds on whether you pull out a blue one in the second one and you didn't get the first one right to begin with. Okay? So, excuse me. So that's the difference between independent and dependent. Okay? A lot of times the things that you're going to do, A, has to be contained in one atmosphere. Okay? In other words, you're dealing with a deck of cards, and both things need to happen out of that one deck of cards. You're dealing with the marbles there, and everything is coming out of that jar. Okay, for it to be dependent, you're usually coming 2 events out of the same thing. Okay, now, that's what, for example, when somebody plays 21, you play cards, play 21. Okay, well, what they're doing is they're weighing the probabilities. For example, if me and Grant are playing 21, and I give him, he has a king face down, and then he has a 5 showing, and I have a king face down, and I have a 5 showing, okay? Well, our odds to get 20, or our probability to get 20, went drastically down. Why? Because there's only 2 5s left in the whole deck, okay? Because 2 of them are sitting right here. So that's what guys that are real smart, they call them card counters, can go in and keep track of cards and know what's been played and know what's left, and then they can do whatever they're going to do accordingly. Okay? And so there's, a number of cards, okay. You think about this. If you think about, okay, I need to get to 21, I'm already at 15, then that means anything 7 or above is going to bust me. Okay? Anything 7 or below is not going to. Well, at this point, the odds or probability of that happening are pretty even because we each both have a card out of the greater than 7 group, and we both have a card out of the less than 7 group. Okay, so it's pretty even as far as that goes, but the problem is that there's only 7, 8, 9, 10, king, jack, queen. Okay, those are all cards that are available there. Okay, and then you have 6 available here. So it's pretty even. So, it's a 50-50 split, they would say. Okay, so these are all things that are dependent events. Okay, they're independent. If you were sitting there playing 21 and he's playing with one deck and I'm playing with another deck, they would be independent of each other. Okay, because he's, what we are both going to get is totally independent because we're playing with 2 different decks. All right, so that's the difference between dependent and independent. Now, how we figure the probabilities. Okay, the first one that they're going to talk about is how to figure the probability of an independent event. Okay, the probability of an independent event is the probability of A times the probability of B. Okay, these are independent events. Okay, they have given us an independent event there in example 2. Said as a contestant on a game show, you need to spin the money wheel at the right, which is divided into equal sections. Find the probability that you will get a 200 on your first spin and go bankrupt on your second spin. Okay, well, the probability that you're going to get a 200, there's obviously 2 of them, and how many total spaces are there on the wheel? 8. So the probability then, the probability that you're going to get 200 is equal to 2 over 8, which is 1/4. Okay, the probability that you're going to go bankrupt, there's only 2 of those, or there's only 1 of those on there, so the probability of that is equal to 1/8. So the probability that you're going to spend 200 on the first and bankrupt on the second is equal to 1/4 times 1/8. Okay, 1/4 times 1/8 is 1/32. Okay, now they have changed it to a decimal. Okay, so they went and did this. One-fourth is 0.25 times 1/8, and what is that? 12.1275. 125, yeah, 0.125. They multiplied those out, and they got what? 0.03125. Okay, so that's the probability that you would do a 200 and a B. So basically a 3% probability. So, Emma.
Do I have to change it to a decimal when we're working?
I believe, if I remember right from this lesson, most of them are going to be in decimal form. And so, yeah, I'll go ahead and just put them in decimal form. That way we'll, divide the bottom into the top. Do you have a concussion or something, dude? All right, now, probability of a dependent event. These are very similar in their formulas. Okay? Now, the probability of a dependent event is going to be the probability of A times the probability of B given A happened or occurred. Okay, here's what they're talking about. That one. Okay, have 4 different colors, yellow, green, purple, blue. Okay, I want to know the probability that I pick a purple color, then a green color. Now, once I pick them, they are no longer there. I am keeping them. Okay? So, then what is the probability of purple? What? 3 over 12, which is 1 over 4. Now, we're going to assume that the purple occurred. Means it's no longer there. Now, what is the probability that I choose green? What? 3 over 11. Now I multiplied those two things together. Okay, if we want it in decimal form, 3 over 40 to 4 doesn't go into 30. 44 goes into 300 7 times. Nope, going to have to be 6. 4, carry my 2. 264. Be 36. Bring down my 0. 4 into that's going to go 8 times. Yeah, 8 times. It's going to be 2. 352. Remainder 8. Bring down my 0. Okay, so we'll just call it 0.0681. Okay, now any of you, the ones you're going to have, they're either going to end, they're going to terminate, or they're going to repeat. Okay, or the directions are going to tell you to round it. Okay, that one, 44, it may go on for 10, 11 digits before it stops, or does repeating. Let's see here.
So we only need the first one.
Let's see, what was it? What? 3 over 44? That's going to repeat the 81818181. Because they're rounding. They ran out of digit places, and so they're rounding the 1 to 2 because there was an 8 next. So basically, you could do this right here for this one. Okay. So that would be the probability given that situation. Okay. Remember, we had a purple right here, and we circle it. Okay, when we got it, so it becomes that. That is a dependent event. You are assuming that the first event did occur, and then you get to your second event. Okay? All right, let's look at some examples. Let's look at number 2. In the directions, they've told you that this is an independent event. Okay, they have told you that it is an independent event. Okay? So it says event A and B are independent events. Find the probability of A and B. So number 2 says the probability of A is equal to 0.3. Probability of B is equal to 0.7. So for an independent event, you just simply multiply the two probabilities together. And so when you multiply 0.3 times 0.7, that's 0.21. So the probability of A and B equal 0.21. Okay. Now, if you look at number 5 is dependent events. Okay. But they've already really given you the information you need. You really don't have to even figure out anything. It says if A and B are dependent events, find the probability of A and B. Okay, number 5 says probability of A is equal to 0.9. Probability of B given A equals 0.8. So they've already told you what the probability is. You don't have to figure it out. There's nothing to figure out. They've already given you the probability. So I just simply take 0.9 times 0.8. 8 times 9 is 72. I have 2 decimal places. So it's 0.72. Okay, now, the difficulty arises when you get to one like number 12. Number 12 says the probability, it says they're independent events. It says the probability of A equals 0.2. Probability of B equals question mark. Probability of A and B equals 0.08. Okay? So, I have to figure out what is missing. Well, if our probability formula is this, the probability equals the probability of A times the probability of B. Okay, well the probability is 0.08. That's equal to the probability of A, which is 0.2, times the probability of B. So to solve that, I have to divide both sides by 0.2. Okay, you divide 0.2 into 0.08. We have to move it one place there, so we have to move it one place there. So that's 2 into 0.8, and that's 0.4. So the probability of B equals 0.4. Okay, and you do that whether it's dependent or independent, doesn't matter. You still do the same thing. They're going to have some of those that are dependent where they're missing one of them, and you do the same thing. All right. Your homework. We got about 17 minutes left in class. 13.6, 2 through 20. $13.6, 2 through 20. I'll let you break up into groups of no more than 4.